This is Gemini 3, the first of the manned-Gemini missions back in the 60s, the earliest days of manned space exploration. The total of 12 Gemini missions had several main objectives, including the investigation of long-duration space travel, extravehicular capability, re-entry flight path control, and the conduction of scientific experiments. Gemini 3 completed 3 successful orbits on March 23, 1965, which marked the beginning of 19 months of manned space accomplishments. The long-duration investigations were crucial to future space travel, because if man could not tolerate extended periods in zero gravity, extended space travel may have remained in the realms of imagination. Long-duration flights tested the endurance of both spacecraft and crew. On the spacecraft side, Gemini 5 was powered by fuel cells for the first time. They replaced conventional batteries. Fuel cells were also used successfully on all missions from 7 through 12. This was important because batteries were inadequate for many future space missions at the power levels needed. Apollo, for example, would use similar fuel cells. Medical aspects of the flight were closely studied for such everyday matters as the ability to eat and sleep in space. When astronauts Gorman and Lovell completed 14 days in Gemini 7, it offered much-needed data. Planners then knew they could medically commit crews for flights of up to 30 days. This footage shows the first rendezvous between two spacecraft ever, as Gemini 6A comes within a foot of Gemini 7 while in orbit. At the 11th rendezvous on Gemini 12, this photograph of a solar eclipse was taken. For those who followed the flights from the sidelines by listening to reports on television, rendezvous seemed almost like an automatic exercise. But simply because it was done well did not mean that it was easy to do. Rendezvous required 3 years of theoretical preparation, integrating space mathematics into the constraints of the mission and its hardware. Approximately 100,000 hours were spent on computer computations. When crews were assigned to specific rendezvous flights, each primary and backup crew trained for approximately 400 hours in flight simulators, a total of almost 5,000 hours of rendezvous simulation. Gemini 9A gave NASA its first sophisticated rendezvous experience. 3 different approaches were completed within 24 hours, each of a different nature, to test the practical execution of what was until then all theory. A dual rendezvous was performed between Gemini 10 and the Agena 8, a passive target vehicle still in orbit from an earlier launch. Gemini 11 achieved what is known as a rendezvous in the first orbit, a rendezvous that was practiced in the event of a lunar approach abort. During the first rendezvous, Gemini 6A had moved to within a foot of Gemini 7, but of course the two could not dock. The first space dock came in March 1966. The spacecraft was Gemini 8. Astronaut Armstrong moved in very slowly while making his final approach until he was about 3 feet from the target. He then held his position. Once docked, the Gemini Agena configuration stayed stable for almost 30 minutes. Gemini completed 9 successful dockings, most of them performed in the final 2 missions, 11 and 12. In short, with Gemini we learned we could assemble an orbital workshop and conduct scientific experiments in it for extended periods of time.